Good evening, everybody. Welcome back. Welcome back to another session of domain analytics. So we were discussing on the oceanography analytics. So today was the day 2. So we were discussing on types of the oceanography analytics. So let us discuss what we have learned yesterday. So we will take a on the oceanography. We are discussing on the what are the types are the oceanography analytics. So there are 5 branches of oceanography analytics. So they are biological oceanography. Let me write here. Biological, chemical, then we have geological oceanography analytics, then we have physical, then we have paleoceanography. So these were the 5 modules, we can say 5 types of the oceanography analytics. So we were discussing one by one yesterday. Today we will discuss on after the next step, which is called as Crypts MLQ. So what is Crypts MLQ? What will be coming in this Crypts MLQ? And what will help this to our use cases that we were discussing on yesterday on the oceanography analytics. So let us discuss one by one. So in the Crypts MLQ, let us know what is the agenda for today. So we will learn stages of analytics. What will be the stages of the analytics? How many stages will be there? What all will there? Then we will learn Crypts MLQ. Then we will learn Crypts MLQ methodology. Then we will learn interfacial statistics, unsupervised, supervised learning, data split, error functions. So we will learn one by one, step by step, all these things. Let us start with the stages of the analytics. So before moving to stages of analytics, first we will know what is Crypts MLQ. Okay. So what is Crypts MLQ actually? So I will write here. Yeah. So what is the full form of Crypts MLQ? So it is called as cross-industry standard process for machine learning so this is called as Crypts MLQ. So the full form of Crypts MLQ is cross-industry standard process of machine learning. So in that, what is Q stands for? Here, Q stands for quality assurance. So Crypts MLQ is cross-industry standard process of machine learning with quality assurance. This was about the Crypts MLQ definition. So the machine learning community is still trying to establish a standard process So they were establishing standard process of model for machine learning development. As a result, many machine learning and data science projects are still not well organized. So to organize these things, Crypts MLQ is introduced. So results are not reproducible. So in general, such projects are conducted in an order manner. So to guide ML partitions errors through the development life cycle. So this cross-industry standard process for the development of machine learning application with quality assurance methodology, Crypts MLQ was recently proposed. So it was proposed recently. So we review the core phases of the ML development. Okay. So there is a particular order of individual stages. Still, machine learning overflow was one of fundamental, iterative, and exploratory, so that the depending on the results from the later phases, we might re-examine earlier steps. So we have some steps that are business understanding, data understanding, data engineering, data preparation, machine learning, model engineering, quality assurance for machine learning applications, deployment, and monitoring and maintenance. So we will learn this step by step. Before that, let us start with some stages of analytics. So we will start with descriptive analytics. So we will start with descriptive analytics. So what is descriptive analytics? So descriptive analytics describes the use of the range of history data to draw comparisons. To draw the Comparisons. Most commonly reported financial metrics are a product of descriptive analytics. For example, year-over-year pricing changes, month-over-month sales growth, the number of users, or the total revenue per subscriber may increase or decrease. So what are the uses of the descriptive analytics? So we can tracking social media, so my mistake, my bad. So tracking social media engagements. So this was the first use case. Then we have another use case, that is streaming. We can say live YouTube live streaming and e-commerce things. So streaming is like YouTube streaming or streaming videos, anything related to streaming. And another we have an use case. Learning management. Learning management systems. So here we have use cases on the descriptive analytics that are tracking social media engagement, streaming and e-commerce. Then we have learning management systems also. So how does descriptive analytics work actually? So all data analytics techniques, descriptive analytics is perhaps the most straightforward. So it involves praising, you can say breakdowns, data and summarizing its main features and characteristics in the way in the descriptive analytics. So it present what has happened in the past without exploring why or how. So because it is merged explanatory descriptive analytics, which is use basic descriptive statistics. So that includes measures of distribution, which has frequency or count. Then we have central tendency, mean, mode, and median, and variability, such as variance and standard deviation. Where relevant, it means it also measures the position of various data points, includes the interquartile or percentage range. So how descriptive analytics is used in data analytics, data science or data analyst field. So data analysts can use descriptive statistics to summarize more or less type of data. So all through, it's helped to think it's as the first step in a more protected process. So this become while we are descriptive statistics may decrease the trend or pattern. So we have some advantages and disadvantages of descriptive analytics. So I will write here the advantages. We have present otherwise complex data in an essay distinguishable format. So it provides direct measure of incidents to the key data points. You can say as direct measure. First point. Then it is inexpensive to and only requires basic mathematical skills to carry out. Inexpensive. It is faster to carry out, especially with help of tools like Python or MS Excel. So it relies on the data that organizations already have access to. So meaning there is no need of source of adding in the data here. So this was about the descriptive analytics. So next we have diagnostic analytics. So diagnostic analytics is a form of advanced analytics. So that examine data for content to answer the questions. Why did it happen? And it is characterized by the techniques such as drill down, data discovery, data mining, and data correlations. So the purpose of the diagnostic analytics is to determine the root cause of an occurrence of the trend. So often a trend, it is identified using an earlier descriptive analysis steps. So the company can also apply diagnostic analytics also. So because of diagnostic analytics is used to identify the origin of business issue and fraud issues, or finding approximate solutions to prevent them from happening in the future. It is also called as the root cause analytics. So this was our diagnostic analytics. Then we will discuss about the predictive analytics. So what is predictive analytics? So predictive analytics is the branch of advanced analytics. So that makes prediction about the future. Prediction prediction of the future. So the outcome using historical data, so combined with statistical modeling data, mining techniques and mining learning, companies employs predictive applications. Companies predictive analytics to find the pattern in this data to identify the risk and the opportunities. So predictive analytics is a form of a technology so that makes prediction about certain unknown in the future. So we can't see the future, but we can predict that this may happen, that may happen. We can get a profit or loss in this business field. So we can have prediction in this predictive analytics. So it draws on the series of techniques to make this determination, including artificial intelligence and data mining. And machine learning, modeling, and statistics as well. So for instance, data mining involves the analysis of large set of data to detect patterns from it. Then we have text analysis, which does not same expect from the large blocks of the data. So predictive models are used for all kind of applications. So including weather forecast, creating video games, translating voice to the text for mobile phone, messaging, customer services, investment, portfolio development, all these things. So they are also useful for business to help them and manage inventory, develop marketing strategies. So forecast says it also helps business survival, especially those in highly competitive industries such as healthcare and retail. In investors and financial professionals can also draw the technology help craft investment to reduce their potential of the risk to predictive analytics. So this was about the predictive analytics. And last we have prescriptive analytics. So prescriptive analytics is a form of advanced analytics, so which examine data or content to answer the question. Excuse me. So what should be done, or what can we do to make it happen? So in such characterized by techniques such as graph analysis, simulations, complex events, and event processing, neural networks, recommendations, all these things. So the definition of the prescriptive analytics is used in the advanced processing and tool to analyzing the data and content to recommend the optimal course of the action or the strategy moving forward. So the prescriptive analytics, the form of data analytics that help us business to make better or more informed decisions. So its goal is to help answer questions about what should we do to make something happen in the future. So it works on the how do we get to this point? Same as through its replies on the artificial intelligence, AI techniques, such as machine learning and the ability of a computer program without additional human input, and to understand and advance from the data. So it is adapting as well the data, and here the machine learning makes it possible to process a tremendous amount of the data available today as a new or additional data become available to the computer programming, which is adjusted automatically to make use of it. So in this process, that much faster as more comprehensive than the human capability could maybe manage in the prescriptive analytics. So this was about the 4 stages of the analytics. So when we move to this Crypts MLQ, here we have which is described in 6 phases. So they are business and understanding, data understanding, sorry. Then we have data preparation and data engineering. Then we have model building and tuning. Later on, we have model evolution. So how a model will be evolved the data science through Crypts MLQ. Then we have deployment, how a model will be deployed in the data science, or we can say in the Crypts through Crypts MLQ. Then we have monitoring and maintenance. So these are the 6 stages of the Crypts MLQ process. We will learn one by one all these things. So I will show you the mind map so that you can easily understand. Here we are using mind map of 360DigiTMG. You can also look into this mind map through our website. Yes, go to Google and type 360DigiTMG mind map. You will be available. There are many more mind maps for the different course. You can just go through it for your knowledge. So here we have the 6 stages of the Crypts MLQ methodology. One minute, guys. Yeah, so these are the 6 stages of Crypts MLQ, cross-industry standard processing for the machine learning with quality assurance. We will learning one by one all the 6 by today. Let us start with business understanding. So in the business understanding, first we have to record the business objective. So what is the objective? So what is a business objective means? So a business objective is a container of application data such as customer or any invoice data. So data is exchanged between components by business objective. So the underlying structures of a business objective is an XML scheme definition XSDs. So how do you identify business objective first of all? To identify the business objective, in a business environmental that are related and about which data is or needs to be stored. For employees, projects, customers, appointments, students, products, orders, supplies, all of these are objectives, objects. about which organization stored the information on a business object, as same as with the business constraint. So business constraints are the mechanism to add lifting conditions with a scenario. So the conditions could be based on the existing business constraints, procurement policies, or the business rules. For example, a favorite supplier rule, award limit rule, or a supplier quote rule, or the total cost rule, etc., can be defined as a scenarios. The business constraints. Then we have success criteria. So in the success criteria, we have business success criteria, ML success criteria, and economical success criteria. So there are three different success criteria. So these are the three success criteria. So here we can have business success. What will be the business success criteria? What will be the ML success criteria? Then economic success criteria will be there. Then we have it is recommended to write the objective and constraint using 2 or 3 words. So it should be recommended to write the objective and constraints. And it's also recommended to use the data optimization terms. For example, let us take minimization, maximizations. Then we have project chart. See, in this project starter, this is the first documentation which project gets prepared on any project. So in the second point, this contain details at high level. Yeah. So it is high level product can say characteristics. Then we have high level projects requirements. Then we have summary milestones, summary budget. What will the milestones what will be the budget, what are the stakeholders. Then we have high level risk, what will be the risk in the project. Then we have the documentation is signed for project sponsors. So this was about the project chat. So this was about the business understanding. In this, we have data understanding also. So before that, let us go to our slides. That anything that we have missed here? No. Yeah, the data types we have continuous data, discrete data, quantity versus quantitative data. Then we have structured or semi-structured versus unstructured data. We can have big data. What if someone have non-big data? What someone has time series or cross-sectional data, or the longitudinal panel data also. Sometimes it is balanced and imbalanced also data. Sometimes we have offline data available, then sometimes we have to extract the data from the live streaming data. Yeah, you can see in this continuous we have two things that are internal and ratio. Then in internal we have subjective, for example, temperature 20, 30, 40, etc. Which are merely counting. Then we have ratio, which is most preferred. For example, weight and height and age, all those things. Then we have data which can be represented in decimal format and makes sense about the continuous data. In the discuss we have categorical. In this we have binary and multiple. Yes, you can go through this mind map. In the discrete data, we have categorical and count. In the count, so in the category, we can use binary, multiple, on nominal. Then we have some examples. For example, gender, color, and numbers. In the multiple ordinal, we have ranks. So for the military ranks, we have second lieutenant, first lieutenant, captain, major, colonel, etc. Then we have structured data. So is that which can be represented in tabular form for the data. Then we have structured and semi-structured or unstructured data. So semi-structured data is the data which is not provided in tabular format but can easily transform into the structured tabular format. For example, HTML or XML. Then we have examples for the unstructured data, which cannot be placed in a raw state or in the tabular format. They are videos, images, audios, and textual data. So this was about the structure. Then we have data or non-big data. So here the volume is a huge volume of data, and in velocity, the data generated at a rapid speed. And here the variety videos, images, audios, and text example. And we have cross-sectional. In that cross-sectional data, it can be sequence in which you have data does not matter here, which has variables. You can say multiple variables in that. The time series data, time and the data and sequence in which we have the data matters. So data should always be arranged in the sequence in the order, we can say, or in ascending or descending order. It has single variable and one time variable for sorting in sequence. Then we have balance, imbalance. So data should be balanced. If it is imbalanced, it will be difficult to understand the data. In the balance, we use simple random sampling. So this was imbalanced data. Then we have offline data versus live streaming data. As I told, live streaming means live data types. Here in the data collection, we have primary data source, secondary data source, data version control. Then we have data description, data requirements, and data verifications. You can see in the data, primary data source, data collected at a source. So to get the data, exact variables of the internet, costly and time consuming. So examples are, we can say, surveys. So the design of experiments simultaneously and web scraping, social media extraction, IoT sensors, etc. IoT sensors data can also be secondary data for data primary data source. as same for the secondary data. So data is collected before the hand. For example, RDBMS, CRM, FRM, SCM, HCM, SQL databases. And also publicly available data, open source as well as syndicate data also. Then we have data version control, where modified the data sets should be documented in that data version control. For the data descriptions we should be described by the statistical properties in the information about the format of the each input is required for the domain knowledge. And data requirements is it should be have some features, values, and some format of the data set. And in the last, data verification. So the initial and added data have to be checked according to the requirements. The best practice is to use the data exploration technique to investigate the sample distributions. So this was about the data collection. Then we have data preparation. In that, we will learn data cleaning, data preparation, data mugging, data bundling, data organizations, exploring data analysis, which is called EDA, Descriptive Analytics. So in this data cleaning, we have all these things: typecasting, handling, duplicating, outliers treatment, zero and non-zero variance, missing values, descriptive binding, dummy variables creations, transformations, and we have standardization, normalizations, string manipulations. We will discuss on the later. In the EDA, we have some business movement decision, first movement, business decision, second movement, business decision, third movement, business decision, fourth movement, business decision, and fifth, we have graphical representation. So in the first business mode, we use measures of central tendency. In that, we use mean median mode. For the second movement, business decision, we use for dispersion, measure of the dispersion. So in that, we find variance, standard deviation, and the range. In the third movement business decision, we have skewness. So we will find out it is negative or positive skewness. So if skewness is 0, then it will be a normal distribution, as we know. In the fourth moment business decision, we find the kurtosis, where kurtosis is equal to 3 means it is normal decision, and then we have negative kurtosis, is also called as the plakotic distributions. So positive kurtosis is also called as leptocrotic distributions. In the graphical representation, we have univariant, bivariant, and multivariant. So this was about the EDA. Then we have feature engineering. So in the feature engineering, we have temporal data, numerical data, categorical data, text data, image data, video data, features extraction. Then in the features extraction, we use automatic extraction, manual extraction, principal and component analytics, analysis, all those things. So we have discussed the models. We will discuss on the PPT point. So here we have some unsupervised learning, how data is trained or the historical data is driven here, how a data is trained or predicted in the unsupervised learning. By seeing this diagram, you can understand the process of the prediction. First, we see the new data. Then we will start predicting. Through machine learning. Then we have some rows and patterns. Then we will be predicted outcome. Here in the supervised learning, the training and validation data is seen. So you can understand by this diagram. Then first we will start with historical data, then we will do sampling and random sampling. Then we will divide the training data set and validation data set. We will do some machine learning algorithms. Then we will predict and validation or through mathematical equations. Then we can validate outcome of our model. Here we have data split or model evolution. Splitting data is nothing but dividing the data into some parts. So here the test and the test on testing data to get errors, accuracy, also a generalization error. So the combined training and validation data to run the model, which has given the desired resultant based on the set of the finalized model parameters. So then test the model of testing data. So it also ensures the model neither overfits nor the variance nor the underfits bias. For the model evolution, here we have an error function. So the error function confusion matrix. So here the precision should be true false and true false plus false positive. true positive to false positive, and the predictive positive should be probability of correctly identification of the random patient with the disease he has having. So I will explain about the confusion matrix. So it is a table. Let me show here this. So it is a table that is used to define the performance of a classification of the algorithm. So for example, the confusion matrix, which is used for the machine learning methods, which allows you to measure recall, prescriptions, accuracy, and AUC and ROC curves. So below given an example to know the terms true or positive or true negative or true false negative and true negative. True positive you projected positive and it turns out to be true. Yeah. Then we have an error function. Some might be some disturbance in the people with my laptop. Yeah, so we have an error function in that where accuracy measures, so where y is in continuous data. Here some of the formulas of the mean error. Then we have here we have mean error, mean absolute deviation, mean square error, root mean square error, mean percentage error, mean absolute percentage error. So these are all the formulas that we are going to use in our error functions. So here we have a model evaluation and tuning. So in the model evaluation and tuning, here we can see overfitting and underfitting. Where we can choose the training, validation, and testing data sets. For the balanced data set, we have to split the random bias, and we have to take 60 into the training and 20 into the validation, and the remaining 20 to the testing. So it will take 80 into training percentage and 20 into testing. So the largest data set to be estimated future years as accurately as possible. So it has large training sets and better estimations. So how large should be trained to be set the here in the outfit overfitting and underfitting. So here overfitting is nothing but a model, a statistical model. It is used, it is said to be overfit when we train with a lot of the data. When we have the lots of the data, large data. When we are trying to get trained so much of the data, it starts learning from the noise in the occurrence data. The entire data sets and the model does not categorize the data correctly. So because of too many details and noise, it will be overfit. The underfitting, same as a statistical model or in a machine learning algorithm, is said to have an underfitting when it cannot capture the underfitting trend of the data. So it destroys the accuracy. So it occurrence simply means that our model or the algorithms does not feed the data as well enough. So this was about the overfitting and underfitting. So in the overfitting and underfitting here model, sorry for tuning, you can check the graph here